Alright, so welcome back, guys. Today we are finally going to get started in the Algebra 2 portion of simplifying rational expressions, which I sort of kicked off in that first video telling you what it is. And an important part of that is you will see rational expressions. I'm just totally making one up here. Maybe something like this. And they come up in fraction form all the time. And we need to be able to simplify that because oftentimes they just look more complicated than what they are, and we can really break it down and simplify a lot of things. And that's what we're going to do today. So before we start with that, let's just remind you how we reduce regular fractions with numbers. So looking at this first one, I can reduce this because 24 divides by 6 and 6 also divides by 6. So if you divide them both by 6, you get 1/4. And I can do that without a calculator. I know that at this stage in the game, we are used to using our calculators, and that's no big deal. I will never ask you to reduce fractions like this. Like that, this won't be like a problem by itself. This would be embedded into another type of problem. The reason I'm showing you this is because we're about to do this with variables, and you need to understand what is the math that you're doing in your head so quickly that we forget what we're actually doing. Like, how did I get to this? How did I know to divide both of them by 6? Technically, what we did is we wrote out that 6 is 1 times 6, and 24 is 4 times 6. Since there's a 6 on top and bottom, those cancel, and that's what you have left. That's technically what we're doing. Let's write that out. Let's write that out with 15. So that's 5 times 3, and 12 is 4 times 3. The 3's cancel, so you're left with 5/4. That is your simplified fraction. Again, another way of doing that is just looking at both of these and dividing by 3 and writing your answer down. Either way, that's what you're doing in your head. Okay, so let me show you the property, how that sort of swings us up from Algebra 1 and into Algebra 2. So that's the property that I just talked about, where if there is something on top and bottom, they cancel, and you're left with just whatever's left. Now, the important thing is, though, remember you cannot divide by 0. So it's important that whatever was in the bottom to begin with, not when you finish, but to begin with, cannot be 0. And so that's what it says here. B can't be 0 and C can't be 0 because you cannot divide by 0. So that's really important that we specify that. Okay, so let me give you let's jump down to like this example. Notice how there's an x plus 3 in the top, so you can cancel that. And there's an x plus 3 in the bottom, so you can cancel that. That won't cancel with both of them, because there is only one x plus 3, so you have to pick one of them that it cancels out with. And then this gives me whatever's left over. So this part down here is what brings us up into Algebra 2, is that we're not just going to cancel numbers, we're going to cancel like entire expressions like that. But that's all it is. There's nothing crazy to it. We're just canceling expressions instead of numbers. Okay, so you might look at this and say, well, where's the expressions that match that I can cancel? And the answer is you have to make them by factoring. So when I look at this, it's a quadratic that can be factored. And hopefully we get pretty quick at writing this out. Since that's a leading coefficient of 1, it's just going to be x times x is that first term. And let's think of factors of 12 that add to get me to -4. If it helps you to write them out, let's write them out. So that's 1 times 12, 2 times 6, and 3 times 4. Which of those three will get me to -4? Well, that would be 2 and 6. And I'd have to make the 6 negative. So -6, +2, those numbers multiply to get me to -12, so we're good here, and they add to get me to -4, so we're good there. Okay, and in the denominator, we also can factor this because that's just a difference of squares. So that's x plus 2 and x minus 2. Okay, again, how did I know that? You can think of this as a quadratic where the middle term is 0. And then you can think, what are numbers or factors of 4 that add to get me to 0? And that would be -2 and +2, which is why I have those as my filled in numbers. Okay, so now from here I can see that I have matching terms that will cancel each other out. And so what I'm left with is x minus 6 over x minus 2. But there's one caveat. If you write this, you will not get the answer correct. The reason is because there's one thing that you need to specify. Is before we started getting all cancel happy and started canceling things out, look at this term here. What is a number that x could never be because it will make us divide by 0? Well, this term right here that I canceled out, if this x is negative 2, then this term in green would be 0, and then we'd be dividing by 0, which cannot happen. So x cannot be negative 2. And if we have that added criteria, then these two things are actually equal. So let me just erase all this markings I have. Because what we're saying here is that these two things are equivalent. That's what these equal signs are. So we're saying this thing right here is the exact same thing as this. And that's only true if you say that it equals the part in red as long as x does not equal negative 2. Okay, because this part right here that we just simplified it to, this part I'm circling in green, if you just look at that and you think about plugging in negative 2, that's no problem. You're not going to get 0 in the denominator. And that's why you have to add it in. Because if you just look at this part, you might think that negative 2 is no issue. But it was an issue because it came from something that we had canceled out. That's why you add it in. Okay, so the other question you might be, and I'm hoping actually that you're wondering this, is, well, what about this parentheses? Shouldn't we add something in about how x cannot be 2 because of this parentheses? And the answer is, no, we don't have to add it in, because when we do the simplified version, we still have that term, x minus 2. And it's you can assume that the person reading your work is smart and they know that x cannot equal 2 here. And so we don't have to like specially say that. There's nothing like where we have to say that just for the heck of it. The only reason we're saying this one is because when you look at my final simplified version, it doesn't look like negative 2 would be an issue. We just know secretly that it was because we had canceled it out up here in our medium, our sort of like middle step. Okay, long story short, any of the ones you cancel out, you need to clarify the restricted domain. Any of the ones you don't cancel out, like this one, I did not cancel out, so I don't have to say anything extra about that. All right, we're going to do lots more of examples. So I'll do a couple with you, and then you'll do a couple on your own. So looking at the first one, it's already factored. These x plus 1s cancel. That was the term I canceled out. So that's the one I need to be clear about, the value of x. So this equals that, but x cannot equal negative 1. Then I'm okay. And again, the reason I say that is because if you just look at this part, if x is negative 1, there shouldn't be an issue. And so that's why we have to specify that, hey, it's true, but x can't be equal to negative 1, because up here in this stage where I canceled things, it was an issue. So if you were just giving me like an answer and I never saw this step, that's why we have to tell the reader, we have to box it in our answer, because we know that this came from this sort of middle step here. Okay, let me clear this, and let's do the second one together. So this part can be factored. Let me factor that. The top looks good to go. The bottom part, that's difference of squares, so that's going to be x plus 4, x minus 4. The part that cancels is the x plus 4. So that's the only part I have to restrict the domain, so I know that x cannot be equal to negative 4, because that is, if you plug in negative 4, that would be 0. But what's my actual answer? Well, on the top, everything cancels, so that's just a 1, not a 0, a 1. And in the bottom, you have x minus 4. That just came from this part over here that did not get canceled out. Okay, typically you put a comma in between like the fraction and whatever the extra piece is that you're saying. You typically put a comma there. Okay, let's do another one. So this one, let's see, what's canceling? It looks like nothing's really canceling. There's no possible way I could simplify 4, and that's not canceling with any of those. So there's really nothing to do here. This is already in simplified form, and so we're good to go. There's nothing to say. There's nothing that I need to do. We are already done. Again, the only time you have to do a restricted domain, and when I say restricted domain, that's when I say like x can't equal some number, is when you canceled something out. But we're not canceling anything out here. All right, and I lied to you when I said this is a you try, because here I am pretty much doing them for you. But since I'm on a roll, I'll just keep going. So let's do the last one. I'm going to write it in the middle of the page to give me more space. Both of these can be factored. So this top one, factors of 3, that's just 2 and 1. 3 and 1. I know I have to make the 3 a negative because I have to add to get me to negative 2. So I know that that's how I'm going to factor the top. And now let's factor the bottom. So factors of 6, 1 times 6, 2 times 3, and choose the ones that add to get me to negative 1. So that would be the 2 and the 3, but since I want to add to get me to negative 1, that means the 3 has to be negative. Okay, so what's canceling here? It looks like the x minus 3's are canceling, and so my answer is just going to be this leftover part, x plus 1 over x plus 2, but I have to say that x cannot be equal to 3. And the reason I say that is because I had canceled it out over here, and so if x was 3, that would be an issue. And there's my answer. Okay, so the next part of this lesson is honestly very similar, but we're going to be multiplying together expressions. So let me just remind you how multiplication with fractions goes. It's really easy, you just multiply straight across. So if I had something like this, where I'm multiplying these two things, I multiply the top, that's why I get AC, and then multiply the bottom, and that's why I get BD. And if you could simplify that, you would. And I do want to specify that B and D cannot be 0 because those are on the bottom. Okay, so how does that go with Algebra 2 looking fractions? Well, you multiply everything together. So regular numbers can multiply, so let's actually do this. So if I multiply the top row, 5 times 6 gives me 30. The x squared times the x gives me x cubed. And then the y cubed has nothing to multiply with, so that's why I just still have the y cubed. Okay, and in the bottom, the 2 and the 10, that's why I got 20. And then the x didn't have anything to multiply with, so it's still x. And then y squared times y is y cubed. Okay, now lots of things are canceling here. So first of all, I think it's a little confusing how they broke this down. So I just want to take this and sort of do our own work on it, because I think they broke it down almost too much to make it look a little long and confusing. So let's just do things we would probably naturally do. The y cubes, those would cancel. And then the 30 divided by 20, we know we could just write that as 3 divided by 2. And then x cubed divided by x is x squared. And so that's my answer, is 3x squared divided by 2. How did I know that 3x cubed divided by x was x squared? That's just an exponent rule. If you have the same base and they're being divided, you subtract the exponents. So that's why I wrote that. Okay, so let's go back and just think about what did we cancel? I canceled out these y cubes. So I would just have to make sure that I say y cannot be 0, because if it was 0, then up here before I canceled them would have been an issue. And also, one other thing I canceled was technically this x down here, because I canceled it and made it just an x squared in the top. So I also want to say, I didn't really save room in my box. Let me erase that. I also want to say that x cannot be 0, because I technically canceled that one there. Okay, so you just reduce your fraction. Anything you canceled, you make sure you say that it can't equal to 0. That's all there is to it. Okay, let's practice. So let's first put these together. So 7 times 8 is 56. X cubed times x to the 4th is x to the 7th. And then y times y cubed is y to the 4th. And in the bottom, 2 times 4 is 8. X doesn't have anything to multiply with, so just x. And then y squared times y is y cubed. Okay, so let's see. How does this simplify? Well, 56 divided by 8 is just 7. And then 7, or x to the 7th divided by x is x to the 6th. So I technically canceled that one. And so I do know that in the end, I'm going to have to say x cannot equal 0. So I'll make sure I add that in. But first, let's finish the problem. Let's look at the y's. Y to the 4th divided by y cubed is y to the 1st power. You could also just leave that as y. And so technically that canceled. So this is my answer, but I have to make sure I add in that x cannot be 0 and that y cannot be 0. and then I'm good to go, because those are the ones that I canceled and reduced the exponent. Okay, and that's it. That's my answer. All right, so let's do another one together. So this one is telling me to find the product, so I want to multiply it together again. But this would be absolutely insane if I just start like foiling everything. It would be so crazy, so many terms, way too hard. What you first want to do is, if you can factor, because then a lot of things normally cancel out. So this term right here, let's just work with the blue one before I even multiply it by, I'll make this one green. Okay, so looking at the top, I can take out a GCF of 3x, and what would be left is 1 minus x. And then in the bottom, looks like this is a regular quadratic, so I can factor xx. What are factors of -5? So let's just write that out. Well, really, there's only 1 times 5. That add to get me to 4. Okay, so that would have to be +5 and a -1. Okay, you might be tempted to say this and this cancel. However, that is not true, because 1 minus x is not the same thing as x minus 1. Just like 7 minus 5 is not the same thing as 5 minus 7. So, as it is, there is nothing that I can cancel with the 1 minus x on the top and the x minus 1 on the bottom. But what I can do is, what if I just look at this top one and pull out a negative? So if I decide to make that negative 3x, so I want to take a negative out of the parentheses, then this would change to a -1 and this would change to a positive x. And then rewriting that, let me actually stick with blue. Just rewriting that to make it look clean then. It's -1 plus x, so I can write that as x minus 1. That's the same thing as -1 plus x. And then notice that matches with the bottom now. So if you ever have something that's really close to being the same, just the signs need to be switched, then go ahead and take out that extra negative if you need to in order to make that happen. Okay, so now the really cool thing is, so let me erase this one because I already have like a cleaned up version, and let me write my blue stuff over here just to condense my work a little bit better. So the awesome thing is before I even work with the green part, I already have things that are canceling just with the blue term. So I can already say these cancel, which tells me that in my answer I'm going to have to say that x cannot be equal to 1, because that would have created a problem with those terms there that I just canceled. Okay, so that comes later. Let's go ahead and do the green part. So I need to factor this, and well, first I can see the bottom won't factor. 3x, nothing's going to happen with that. But with the top, let's think of factors of 20. So I'll write that out. 1 times 20, 2 times 10, 4 times 5. That add to get me to +1. So that would be the 4 and the 5, where the 5 is positive and the 4 is negative. Okay. Then the cool thing is now more things are canceling. Because remember when you multiply fractions, all you're doing, if I go back to this slide and review with you what we talked about, is you just smush together the stuff on the top, and when I say smush, what I mean is multiply, and smush together the stuff on the bottom. And that's exactly what we're going to do here, even with a big fraction. View it as just one giant thing. They're all smushed together. All the stuff on the top is just one top, not two separate. And then when you view it like that, you see more things cancel, like this x plus 5 and x plus 5, this 3x and this 3x. The negative here has to stay, but the 3x will cancel. I think that's everything that cancels. So let me move this x can't equal to 1 over here. X cannot equal to 1. Let's write now just a nice clean version of what I have. So I have this negative here, and this canceled, this canceled, this canceled. I need to write this one down still, x minus 4. And in the denominator, it looks like every single thing canceled. So there's nothing left down here, so I don't need to write anything. But let's write down what is my restricted domain. So we already had this one, that x cannot equal 1. Oops, I meant to erase. And what are all the other things we canceled? We canceled the 3x and the 3x, so x cannot equal 0. because if x was 0, then the 3x down here, it'd be 3 times 0, which is 0. Okay, let me just write that back in. And what else did we cancel? We canceled these, x plus 5 and x plus 5. So in this term here, x cannot equal negative 5, because otherwise this parentheses would have been a 0 in the denominator. So this is my answer. It's negative x minus 4. If you did want to multiply that negative, that would be negative x plus 4. That's probably a better way of doing it, so I don't have to keep parentheses in my answer. I'll just distribute the negative. So negative x plus 4 is my final answer, but I have all these restrictions like x, oops, didn't mean to switch color, x cannot equal 1, 0, or negative 5. Otherwise, this giant expression we had is not actually equal to this really easy, simple answer if it doesn't have these 3 additional pieces. Okay, cool. Let's have you guys try some on your own. So go ahead and multiply things out and write in the proper restricted domains. And when you're ready, hit play to check your answer. Okay, I couldn't help myself but to just walk you guys through it. So the first one, I multiplied everything out, top and bottom. And then 18 divided by 72, that fraction reduces to 1/4. X to the 6 divided by x to the 4th is x squared on top, so technically this one went away, that canceled. And then y to the 4th divided by y squared is y squared on the top. So because that technically canceled and just reduced the exponent in the numerator. So here's my answer, but you have to have this included in your answer. X cannot equal 0 and y cannot equal 0. Because otherwise, if they were in the bottom here, like they were before I canceled and simplified, that would have been a 0 in the denominator. So make sure that's included in your answer, and then you're good to go. All right, check that. I'm going to clear it and then do number 6 for you. So number 6, definitely need to do some factoring before I can tell what exactly is canceling. So this first term here, it looks like I can factor out a 2x. And what would be left is x minus 5. Okay, and the denominator, this x squared minus 25, that's just difference of squares. So that'd be x minus 5 and x plus 5. I can already see something that's canceling, which is awesome. And you know what? Let's just go ahead and cancel them while we're here. And then the other one, x plus 3, I can't simplify that. And the 2x squared, there's nothing I can simplify with that either. But what's pretty cool is you have a 2 and a 2, so those cancel. And then you have an x and an x squared. That almost cancels, but it would only cancel with one of the x's. So I'm just going to take off the 2. If you had 2 x's in the bottom and you canceled one with the top, then it's only going to take away one of them, right? So let me write that in a better way. So that was 2x squared. And what I'm saying, to say it better, is this 2x cancels almost with this 2x, but what it actually does is just drops this exponent to just be a regular x. So the 2's cancel out, no issue, and the x squared in the denominator just turns into an x. Okay, cool. Let's write that out simplified. So in the numerator, that would be x plus 3. In the denominator, you still have this 1x. So I'm going to write that out in front just because it looks neater. And that'd be my answer, except for what are all the things I canceled? I canceled an x down here, so I have to say, oops, not equal, comma is what I meant to write. X cannot equal 0. And what else did I cancel? I canceled this. So x cannot equal 5. Then we're good to go. Then those two things are in fact equal. Okay, and that's it for today, you guys. So if you understand how to apply factoring into breaking it down into these types of fractions and then canceling things and just clarifying what those certain values of x that cannot be based on what you canceled, then you're good to go for today, and I will talk to you guys tomorrow.